It's Frédéric Jehan. I'm not sure, is this completely online or is Frédéric here? It's completely online, so please start the video.
Hello everyone and welcome. I'm Frédéric Jehan. I'm a GIS expert and head of GIS at Egis. Today I'm going to talk about innovating to mainstream digitalization of infrastructure and biodiversity within the Bison project. We will have a special focus on BIM, GIS and digital twins. The topics that we are going to cover today are a small introduction to the Bison project and its overall objectives, a description of the direction towards a digital continuum, and finally the way forward. As all of us came to realize lately, Europe needs to adapt its existing transport infrastructures to new climatic conditions such as floods, droughts, and so on, as well as finding innovative and sustainable solutions to reduce their impacts on ecosystems. As part of the last goals under the EU H2020 program, the Bison project, with its 3 million euros funding, is focusing on setting the ground and upscaling research on transport infrastructures and biodiversity in the next 2021-2027 European Research Framework Program, which is also known as Horizon Europe. 44 partners from 16 countries are working on the project, which is set to end in June 2023. The objective of the project is to help define the strategic research development agenda of the EU. The focus within the Bison project on digital aspects that I'm going to present shortly falls perfectly in line with the EU's Green Deal and data strategy through its February 2022 Data Act for a fair and innovative data economy. One will probably wonder at first, how do you make these three very diverse topics, transportation infrastructures, biodiversity and digitalization, work together? What can be the link between them? In fact, can there be a link at all? One can see that transportation and digital are compatible. Infrastructures are modeled in 3D, monitored via cameras, etc. One can also see in everyday life that biodiversity is somehow linked to the digital world. We see apps for collecting information on the ground, camera traps, etc. Well, explaining the link, existing or to be implemented, between those is the whole objective of the following chapter towards a digital continuum. In order to reach a digital continuum, what are the digital technologies or concepts at hand to make biodiversity and transport infrastructure work together into the digital environment? One can mention about geographic information systems, also known as GIS, building information modeling, known as BIM, and digital twins. Both transportation infrastructures and biodiversity can fit into all of those three, even though their current level of integration varies quite a lot. First of all, GIS. A geographic information system is a computer-based representation of a 2D map. The geographic information is stored in a database, allowing users to query and retrieve their information on the fly. All famous online navigation systems are based on GIS. GIS are quite useful in handling data over large areas. Traditionally, environmental and ecological data are stored into GIS databases as they are used over vast areas. Some countries are making it compulsory for engineering firms to transfer their ecological observations data onto a centralized GIS platform. This is the case in France, for example. As a matter of fact, it is no surprise to see that the main GIS vendor in the world, ESRI, has its name derived from Environmental Systems Research Institute. It is also interesting to note that of all the disciplines, environmental data is among the oldest and best standardized data in Europe. Many web portals are available in Europe for distribution of environmental open data. On the other hand, the transport infrastructure sector is also using GIS quite extensively, as they cover large areas as well. It is interesting to note that at the time of the conception of an infrastructure, data was built on CAD platforms, and only simplified geographic information of an infrastructure was transferred into a GIS. Building Information Modeling, or BIM, is the next one. This concept saw light in the civil engineering construction industry. For the EU BIM task group, BIM is a digital form of construction and asset operations. It brings together technology, process improvements, and digital information. It consists in defining workflow for the entire life cycle of an object, as well as defining the data flow, which is the definition of the structure of a data set, how is the data flowing between various parties, and so on. One who has heard about BIM often links BIM to a 3D model, but in fact, the whole background work about data and workflow constitutes the main backbone of BIM, for which the 3D model is just the tip of the iceberg. Nowadays, BIM is mandatory in public infrastructure projects in multiple countries. For example, in the Netherlands, BIM has been made mandatory for public projects above 7,000 square meters since 2012. It is no surprise to mention that BIM is mostly used with transportation infrastructure rather than biodiversity, even though there's been some research being done on the inclusion of biodiversity in transportation infrastructures in France. Biodiversity is still far behind in this field and not yet included into BIM processes. Last but not least is the digital twin. A step further in the BIM approach, sometimes coming from a BIM or a GS model, is the digital twin approach, which is showing growing interest. A digital twin is a virtual representation that serves as the real-time digital replica of a physical object or process. There are no examples to this date of digital twins covering a large area and all disciplines. Geographic digital twins are quite popular in urban planning practices, given the increasing appetite for digital technology in the smart cities movement. These digital twins are often proposed in the form of interactive platforms to capture and display real-time 3D and 4D spatial data in order to model urban environments such as cities and the data that feeds within them. Digital twins are working within the Common Data Environment, CDE, and are capable to retrieve information from various platforms, GIS, BIM, finance, planning, and so on. Digital twin is expected to play a major role in the future of infrastructure management along their whole life cycle, biodiversity conservation, as well as human adaptation to climate change. GIS, BIM, digital twins are very often working together. One is feeding each other and complementing each other. It is to note that it is not mandatory that all three are in place. For some, only one of them will be necessary. As one can see on the illustration, in order to be in the digital world and follow the life cycle of an asset, throughout all its phases from planning to decommissioning, one has to structure or standardize the data, define data and processes workflows, develop models, and monitor in real time those objects to reach the digital twin. Before reaching a digital twin for both transport infrastructures and biodiversity, there is still a long way to go that goes beyond the technicalities. As a first step, it is important that these two disciplines are tackled and mastered within GIS and BIM, and further on can go into the digital twin. As a conclusion, transport infrastructure and biodiversity are two complex interacting systems. There is an urgent need to integrate biodiversity themes into the digital environment of transport infrastructure. However, such a convergence would require the development of a common working culture supported by adapted education and capacity building. The main key is for the EU to provide the guidelines for the standardization of data interoperability. In turn, providing a common definition would enable a virtuous environment for all stakeholders in the field of R&D, AI, or software development, and help both transport infrastructure as well as biodiversity. The ground is now ready in Europe thanks to the new EU initiatives such as the Green Deal and the Data Act. Thank you all. Don't hesitate to ask a question. If you want further information about the project, you can also look at the following documentation, and there is also a list of people who collaborated onto this specific topic.
Thank you, Frédéric.